Hello students, Ms. Slyman here with your 3.4 notes on solving polynomials by factoring. So I started with just this list here of types of factoring that you should know. And the first one, the most common one, excuse me, is to look for a common factor. So in this case we have 4x as our common factor. This is a trinomial, which I've seen you guys are great at factoring. If your trinomial is a perfect square, then you can start to look at this pattern. I don't think this is worth memorizing though. If you know how to factor this, then just use the same technique for all polynomials. Sorry, all trinomials. But difference of squares hopefully is a pattern that you've seen, that if you've got a perfect square minus a perfect square, it factors into a plus b, a minus b. Notice though, if I have a binomial being squared, when I expand that, I don't end up with plus minus. This means this whole quantity squared, x plus 4, x plus 4. Not plus minus is a mistake I see a lot. All right, so now some ones that you might not know. If you have two cubes, so with a difference of two squares, only if they're subtracted does it factor. A sum of two squares does not factor. So we say a sum of squares is prime because it doesn't factor. Prime. So like x squared plus 9 does not factor. But a sum of cubes does factor, and it factors into this pattern of a plus b times a squared minus ab plus b squared. So 8x cubed plus 27, well, that's the same as 2x cubed plus 3 cubed. So here's my a, here's my b, and we get a plus b times a squared minus ab plus b squared. This part is prime. It does not factor again. Much like a sum of cubes, we also have a difference of cubes. Differences factor into a minus b, and then opposite sign on the inside. It's the same for the a plus a cubed plus b cubed. We have a plus sign first, and then opposite sign, always ending with a plus. Factoring by grouping is something we do when we have 4 terms. So if you have 4 terms, one of the things you can do is put them into a group. So in this group, I have a common factor of r, which I can take out, leaving me a plus b. In this group, I have a common factor of s, which I can take out, leaving me a plus b. And then my a plus b is now a common factor for these 2 terms. So since a plus b is a common factor, I can factor it out, leaving r plus s. So this is the same as thinking of something like, ooh, no more highlighter. So if you think of let a plus b equal x, then we would have rx plus sx. So then I have another common factor of x that I could take out. I'd have r plus s left over. But since x is really a plus b, I end up with a plus b times r plus x. So those are our types of factoring, and you should know these types of factoring. So sum of 2 cubes, difference of 2 cubes. You probably didn't know those before, but you might want to memorize them now.